Hey y'all, today we're going to talk about solving linear equations using the graphing method. So I went ahead and wrote down a few tips and I wrote down a few problems that we're going to look at. Now, the first thing I want you to always remember is anytime you are graphing to find your x comma y, your solution to your system of equation, how your answer should be written, anytime you're graphing, you always need to have your equations in slope-intercept form. Now, if you don't know how to do this, you need to go on my YouTube channel, Miss Taylor Tutors Math, and you need to find how to change your equation, change its form into slope-intercept, into y equals mx plus b form. Once you do that, you will be able to graph any of your systems of equations. Well, if you're not sure what I'm talking about, let's look at this problem for an example. I can graph both of these because they are in y equals mx plus b format. Now, looking at this next problem, I can graph the second one, but I won't be able to graph the first one until it is in y equals mx plus b format. That's what I'm talking about. You need to know how to change forms before you are allowed to graph. So let's go back to our tips. Anytime you're graphing to solve for the system of equation, you're going to start with the b on the y-axis. Then you're going to use your slope as your growth. If you have no clue what's going on right now, you need to go back in my YouTube channel, find graphing linear equations, and it's going to teach you step by step how to do this. Now, we're going to look for the lattice point where the two lines intersect, and that is our solution, our x comma y. So let's go ahead and get started. Here's my first equation that we're going to look at. I'm going to slide this over just a little bit and pull out our graph paper. All right, so y equals 5 over 2x minus 4. And our second equation is y equals negative x plus 3. So like I said earlier, in order to graph, you're going to use your b on the y-axis. That's the first thing that you need to do. So negative 4 is our starting point. We're going to go to negative 4 and we're going to make one little dot right there. Now, our slope is 5 over 2x. That's our growth. We are going to rise 5, run 2. 1, 2, 3, 4, 5, run 2. Make a dot. 1, 2, 3, 4. Whoops, let's restart. 1, 2, 3, 4, 5, 1, 2. Do it again. 1, 2, 3, 4, 5, 1, 2. Okay, so I'm going to pull out my ruler and I'm going to draw this linear line. That's for my first equation. Now, let's graph our second equation, and these should line up somewhere. So my starting point on the on the second one is positive 3. So I'm going to go make a dot on positive 3. Now, my growth for my second equation is negative x. So that means go down 1, then to the right 1. We always move to the right. Don't forget that. Down 1, right 1. Down 1, right 1. Down 1, right 1. And you should have just noticed what happened. They overlapped at a perfect lattice point. So what would the solution for this system be? You find the x comma y. X is 2, y is 1. So our answer is going to be 2, 1. That's our answer. We just graphed this system of equation to find the x comma y. Okay, so let's try one that isn't in y equals mx plus b. Remember, your tip says always have it in y equals mx plus b. So we need to change this one to y equals mx plus b. In order to do that, I need to subtract 2x on both sides. So this is going to be y equals negative 2x plus 5. You should notice something. This equation and this equation, they are identical. Anytime they're identical, they are going to graph exactly the same thing because they're both starting at 5 and they're both growing by negative 2. So our lines would actually overlap. Let's show that on the graph. Starting at positive 5. Going down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. So I'm going to make my line. It actually overlapped the orange line, but that's not part of our problem, so we're not worried about that. Let's graph the second one. Start at positive 5, down 2, right 1, down 2, right 1, down 2, right. It's doing the exact same thing. So these lines would overlap. Anytime they are overlapping lines, your answer, you will not have an x comma y because they're overlapping at every single point. When they overlap at every single point, your answer is infinitely many. Infinitely many solutions. That's your answer. You don't have an x comma y because every single point are your x comma y's. So you don't want to sit here and have to write out every single x comma y. So it's infinitely many solutions. Now let's look at the last example I have for you. Notice that the bottom equation is not in slope-intercept form. So you need to change it. In order to change this, you would have to add 3x to both sides. So this bottom would be y equals 3x plus 7. And the top is y equals 3x plus 2. So let's go ahead and graph these and see what's going on. I'll change my color up. Let's see a different color than what we've been using. All right. So positive 2 is where we're going to start on the first one because that's our B. So positive 2 is where our first dot goes. And our growth is 3. So we're going to go up 3. 1, 2, 3, right 1. 1, 2, 3, right 1. 1, 2, 3, right 1. All right, let's go ahead and make a line. Hopefully that's enough. If not, we can always make a few more dots. Okay, and let's look at the second equation. Y equals 3x plus 7. So where are we going to start? We're going to start at positive 7. And we're going to grow by 3 every time. So 1, 2, 3, right 1. 1, 2, 3, right 1. 1, 2, 3, right 1. Okay, they're not intersecting. And even if I would have continued my dots, would they ever intersect? No, they would not, because those lines are parallel. Do you know what makes them parallel? If you look back at your problem, they both had a growth of 3x. So the lines will never intersect. Your answer would be no solution. So the only time you're going to have an x comma y, like our orange lines, is when you have different slopes and different intercepts. I hope this helps. Y'all have a great day.